When you think about coastal flooding, you probably picture a single massive storm crashing ashore. But that's not the whole story. It's actually a combination of powerful forces, some that hit you in an instant, and others that build up slowly, almost invisibly, over time. So let's dive into what's really putting coastlines around the world at risk. Okay, so you hear this term all the time on the news during a big storm, storm surge. But what does it actually mean? To really get the danger here, you have to understand it's not just a big wave. It is by far the most destructive part of a hurricane. So here's the simplest way to think about it. It's a huge bulge of ocean water that gets pushed towards the shore by the sheer force of a storm. And this is not your normal daily tide. Nope. This is an abnormal rise in the water level that can send floods rushing for miles inland. So how does this battering ram of water actually form? Well, it's this incredibly powerful combination of atmospheric forces all working together at the same time to create a potential disaster. It's really like a perfect storm of three things happening all at once. First, you've got these ferocious winds that act like a giant plow, just piling up ocean water and literally shoving it toward land. At the very same time, the storm's super low pressure center creates a kind of vacuum effect which pulls the sea surface up into a bulge. And the final ingredient? The tide. If all of this hits the coast during a high tide, the effect is just massively amplified, pushing this incredible wall of water way, way inland. But here's the thing. The power of the storm itself is only half the story. The amount of devastation often comes down to vulnerabilities that were already there, long before the storm ever even formed. These are the unseen risks that are just baked right into the coastline itself. Some places are just naturally in a tougher spot. Low elevation, that's kind of the obvious one, right? But land subsidence, that's a much sneakier threat. This is where the land itself is gradually sinking, maybe because of groundwater being removed or just the natural compacting of soil in a river delta. And then on top of all that, you have our own actions, like chopping down vegetation and destroying natural barriers like marshes, which basically strips away a coast's first line of defense. Think of a healthy coastline as having its own natural shield. Mangroves and marshes, they act like a giant sponge, absorbing all that wave energy and slowing down the floodwaters. But when we build right up to the edge and remove those buffers, well, there's absolutely nothing left to stop the full force of the water from crashing inland. So all of these local risks we've talked about are now being cranked up to a whole new level by one single global driver. A changing climate is fundamentally changing our oceans, and that's raising the stakes for every single coastline on the planet. So why is the sea level actually rising? Well, it pretty much boils down to two main reasons. First, as the ocean warms up, the water itself expands. It's a simple law of physics called thermal expansion. Second, and this is the one you probably hear about more, ice sheets and glaciers are melting faster and faster, pouring enormous amounts of fresh water into the ocean. So the starting line for any coastal flood, it just keeps getting higher. And if that wasn't enough, here's the real double whammy. Not only is the water level higher, but climate change might also be fueling more powerful and more frequent storms. So what does that mean? It means the very events that create these massive storm surges could become even stronger, and they'll be hitting a coastline that's already more vulnerable because the sea level is higher to begin with. So you see, it's not just one thing. It's the local geography, it's how we build our cities and towns, and it's these huge overarching global climate trends, all intersecting. And that is what makes coastal flood risk such an incredibly complex and multidimensional problem. And this becomes crystal clear when you look at some real-world examples. Take Bangladesh. You've got the perfect storm of risk factors there. It's a super low-lying river delta. The land itself is sinking, and it's right in the path of frequent, powerful cyclones. Or look at the Maldives. They're facing a truly existential threat from just their extremely low elevation. Even a pretty modest rise in sea level could be absolutely catastrophic. And ultimately, that's the key takeaway here. This isn't just an environmental story. It's a human story. It's about where we choose to build our cities, how densely populated those areas are, and how all of our infrastructure holds up against these incredibly powerful natural forces. Okay, so understanding this complex threat is one thing, but responding to it, that's a whole other challenge. Protecting our coastal communities is going to require not just one silver bullet solution, but a really smart combination of approaches. Generally, the responses fall into three main buckets. You've got hard engineering. That's things like building massive seawalls and surge barriers. Then there's soft engineering, which is all about working with nature by restoring those vital mangroves and wetlands. And finally, you have sustainable management, which is really about being smarter, using things like early warning systems and careful coastal planning to keep people out of harm's way in the first place. A truly resilient coast needs all three. So it all comes down to this, doesn't it? The science is clear, the forces driving coastal flooding are getting stronger. The real question is whether our planning, our engineering, and our collective will to act can rise to meet them.